Are you tired of fussing with your benchtop location just to process your samples? Ouch! Looking to process a large sample size, but being held back by only being able to process a small or medium sample size? Are you feeling strapped down by large, heavy, strenuous handheld equipment? Frustrated by not having enough room on your laboratory bench? What a mess!
Hi, I'm Mike Dury.
And I'm Element.
And we're here to talk about the KickA55 XRF Handheld. Did you know that KickA55 is a world leader in producing and manufacturing energy dispersive X-ray fluorescent spectrometers?
I did! Did you? Well, the XRF handheld also offers high performance with just a point-and-shoot simplicity. It's also sealed against moisture and dust, allowing its inside electronics to be 100% safe in multiple environments, even the harshest. So it's allowed on the shop floor or in the field.
Let's take a closer look.
The KickA55 XRF fluorescent spectrometer is a full-blown chemical laboratory that fits conveniently into your hand. It is a safe, reliable solution for on-site chemical analysis without sampling. Light and rugged, it can be used for a multitude of tasks. The measuring process is very simple and takes mere seconds. Here we see the inside of our analyzer. An X-ray beam with enough energy to affect the electrons in the inner shells of the atoms in a sample is created by the X-ray tube and emitted from the analyzer. The X-ray beam hits the sample, displacing electrons from their inner orbital shells of the atom due to the difference in energy between the X-ray beam and the binding energy that holds electrons in their proper orbits. Remember, electrons are fixed at specific energies in their positions in an atom, and this determines their orbits. The spacing between the orbital shells of an atom is unique to the atoms of each element. When electrons are knocked out of their orbit, they leave behind vacancies, making the atom unstable. The atom immediately fills the vacancy from a higher orbit. This is fluorescence. The individual fluorescent energies are then recognized by the solid silicon semiconductor detector. The digital signal processor then identifies what elements are present in the sample and displays this information on the screen. In order to determine the quantity of each element present, the proportion in which the individual energies appear can be calculated by the instrument or by other software using the USB port or our wireless function.
Still not convinced?
We'll show you just how simple it is to use.
Sample prep can be done in one of two ways. 1. Point and shoot, anywhere. 2. Use a mortar and pestle to grind down a material, or just scrape it off, for instance, a toy. Here, we see the home screen. First, we click on Test. Then, we click on Calibrate Detector. It is important to calibrate your detector with one of the standards given when you buy your equipment. This is the end result of the calibration. You want to make sure that your resolution is within a good scale, which you can see on the sheet given in your product. Next, you click on Utilities. This brings you to many options based on what you're searching for. We clicked Standard Soil Mode. There is also mining modes. During the soil mode, you can see each of the elements on the left-hand side and what their parts per millions are. After stopping your test, you can choose to view data. If you're hooked up to a computer, it will then translate into an Excel document showing you each element and how much it read for each trial. You can then use it to choose which data is statistically significant based on limits of detection, as shown here.
It's quite clear our small handheld KickA55 XRF brings lab-grade analysis to the field.
Let's break it down.
Okay, so here is the data from an experiment from Silvermeans, Ireland, where scientists compared the soil pollution concentrations using the portable XRF. They found high levels of pollution in the area surrounding mining activity, especially in the form of these three elements. Here we see the data from a test that was taking place to compare the formation of shales, gas shales, which are fine-grained sedimentary rock, along the same Eagle Ford formation but at two different locations. It showed that there were different amounts of major and trace element geochemistry in the rocks at the two different locations.
Having worked as a professional in lead testing for years, I have had the opportunity to work with this amazing KickA55 XRF. It is one of the most top-notch pieces of equipment we've ever used, and it helps us identify safety hazards without destroying walls for a sample.
Typical uses include the analysis of oils and fuel, plastic, rubber, and textiles, pharmaceutical products, foodstuffs, cosmetics, and body care products, fertilizers, minerals, ores, rocks, sand, slag, cements, heat-resistant materials, glass, ceramics, wafers, the determination of coatings on paper, film, polyester, and metals, positive material identification, the sorting of metal alloys, glass, and plastic according to their constituent materials, and the monitoring of solid waste, effluent cleaning fluids, pools, and filters.